Hello, welcome back to Cracking the Cryptic, and I get to try a puzzle by Nicolas Duhale today, and I don't really know how to pronounce him. I think Simon's gone with Nicolas Duhale, and that might be right, but I'm guessing it's a Frenchified pronunciation, or probably just French. Nicolas Duhale, maybe. Not a name I find easy to pronounce if that is the right way. But the great thing about Nikoli is he's a fantastic constructor of Sudoku, as you will have seen if you watched Simon solving with Merrill Janssen, and you should do, because it's a really interesting puzzle and solved by the two of them in collaboration. Merrill won the prize for March for solving our Sudoku hunt that was our Patreon prize reward, and she was drawn out of the hat having completed it correctly and sent in the correct solution. That was the blobs indexing puzzle pack. April's prize reward was for the Bug Friends by Sandra and Lala, and May's will be coming soon, so do check in with us on Patreon, join us on Patreon so you can have a go at that. There's also gridogram and connections and crossword videos to tempt you, to entertain you. And we'd love you to join us on Patreon. We'd also love it if you tried our apps, and they feature some fabulous line Sudoku, classic Sudoku, and the worms, including Blobs' latest eclectic worm, which is brilliant. So do check those out as well, or the merch on the website, or anything under the video. There's loads and loads of stuff. So look in the description field. When you do look there, the first link you'll see is to try and play this puzzle if you want to. And I'm going to go through the rules now. So, normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3 by 3 box. A clue outside the grid indicates the sum of the first x digits, where x is the first seen digit. So if this digit was an 8, in this column, we would add the first 8 digits, and that would be B. A and B represent two numbers to be determined by the solver. So A will always be consistent in this puzzle and B will be consistent. Doesn't say they're different, but they might be. And now finally, along a teal modular line, any 3 adjacent digits include 1 from the 147 set, 1 from the 258 and 1 from the 369 set. So in your imagination, split your keypad vertically and you will have those 3 sets. There aren't any other rules. The puzzle's called Simple as AB, and I'm not prepared to say the word prepared, but I'm prepared to admit I suspect it won't be as simple as ABC. But give it a go on that first link, and you can judge from the video length how hard I am about to find it. Let's get cracking. So, we have nothing in the grid apart from 3 short teal lines. Outside the grid, we have 6 A's and 6 B's. And we have B's in the same row as each other, and we have A's in the same row. And then we have one column where A and B are in the same column as X sums, adding the first. Well, I mean, my first initial impulse is these could both be low, they could both be quite high. One could be low, well, one could be low and one could be fairly high. Ah, right, I think that is the point. So, a 4-cell teal modular line doesn't tell you much, but it tells you one thing. It tells you that the 2 digits at its end are from the same modular set. And now that's quite interesting. I think it's quite interesting for this line. If we were to colour this line with the modular sets, and I'm just making up colours, that would have to be the same colour as that, because these would be different from each other, say red and blue. They would need a yellow to complete them on that side and a yellow to complete them on that side. That's what the rule means. And that means the 2 yellow cells are from the same modular set. And therefore, those digits are either 3 or 6 apart. But they have to act as the X in the X sum mechanism. Now, clearly we could rule out 1 and 4 as a pair. 1 would only be giving a length of 1, and indeed the digit 1 would be in it. So the x sum for a digit 1 would be 1. And the x sum for a digit 4 has got a minimum of 10 and a maximum of 28. How am I getting that? By thinking of a 4 there with either 1, 2, 3 beneath it, or alternatively 7, 8, 9. Those give you the minimum and maximum, because that 4 means count these 4 cells. So 1 does not pair up as an A with either 28 or 10 or anywhere in between. Now, I guess the next question is, do 4 and 7 potentially pair up? We've got 10 to 28 in the 4 version. The 7 version could be 28. 7 cells, the absolute minimum is the sum of 1, 2, 3, 4, 5, 6, 7. And I'm afraid by now I know all the triangular numbers up to 9. So 1, 2, 3, 4, 5, 6, 7 adds up to 28. So that would match off with the 4, just. And that's quite interesting, because I wonder if we're going to find that other pairs from modular sets don't work. So 2 and 5 would be the lower of the possibles in the middles. Oh, it's worth mentioning, obviously 1 and 7 can't pair together. They're miles apart. But anyway, 2 and 5, with a 2, your maximum is 11. With a 5, your minimum is 15. So they can't match. 5 and 8 might be a match. 5's maximum is 35, 9, 8, 7, 6, 5. 8's maximum is 8's minimum is 36. So they don't quite match. So this is a very good discovery by Nikoli, actually. So they can't be from the 2, 5, 8 set. 3, 6, 9, I don't think that's going to work. Well, a 9 would give you a total of 45. That is the sum of the digits 1 to 9. It's a secret that we sometimes share with you, but lots of you know it. So once you've got 1 9 in the perimeter, like 9 just won't be a perimeter sum, because it would have to appear as, if either A or B was 45, 9 would have to appear every time it said A or B. And there'd definitely be clashes in this column if nowhere else. So can it be 3 and 6? And the answer is no, because the maximum with 3 is 3, 8, 9 is 20. Oh, the minimum with 6, it's very close. It's 6, 5, 4, 3, 2, 1. It's 21. That's really interesting. So if you take 3, 6 as a possibility, 2, 5 as a possibility, they both miss by 1 digit from, no, 5, 8 it was that missed by 1 digit from being possible. And 4, 7 only does it by 1 digit. So that's actually a 4, 7 pair. And one of these is a 4-cell segment adding to 20. Well, 28 is A, and the other is a 7-cell segment adding to 28. Now, we don't know which is which, so I'm going to mark them like this. But we do know now that A is 28. So now I'm going to have a look at this row. If we're having a sum of 28 in the row, for the x sum, the first digit, well, we know what the minima and maxima are. The minimum digit is clearly 4, and the maximum digit is clearly 7. So this starting digit could be 4, 5, 6, or 7 on either side. The same is actually true for these A's down here as well. They've got to be the same. Now, it's not going to be 4 and 5. So what I'm now considering is that if we have a 28 sum from both sides, we know, like every row in Sudoku, the row adds up to 45. The two 28 sums add up to 56. And I think that means there's overlap between those two pieces. Like there might be a 5 piece and a 6 piece, and they would overlap by those two cells. And the overlap will be 56 minus 45. It will add up to 11. So it's got to be at least 2 cells of overlap. Does that help us determine? Not really. It doesn't get any of these numbers out of this cell. There is also, of course, a modularity similarity between this digit and this digit, which sets up B. And over this side, well, no, the trouble is those two A's could be from, probably will be from different modular sets. Although oddly, they don't have to be. I don't know. Oh, okay. One of these columns is 7. What is B? Do we know anything about B yet? B appears twice in this row from both ends. And here. I don't think we've learned anything about B. We might learn something about B. If this was a 7, these digits are 1, 2, 3, 4, 5, 6, 7. These two cells would be 8 and 9. B can't be 9. We've worked out that none of these starting digits are a 9. Oh, sorry, B's X can't be 9, because then B would be 45 and all of these B's on the bottom row would need a 9. That can't happen. So if that's a 7, this is going to be an 8. It's going to be adding the 8 cells that don't include that 7. And that's 45 minus 7, 38. Is there any chance that B is 38, for which the beginning digit would always be, it could be 6, 7, or 8. That would be a 6, 7, 8 triple in the bottom row. And we know that digit would be 8. These would be 7 and 6. Can 6 be in a 38 sum? I was assuming it could be because the maximum sum for 6 digits is 39. If you had 4, 5, 6, 7, 8, 9. 36 can only be achieved for 6 digits by 9, 8, 7, 6, 5, 3, and 6 would be in that. So it is possible. What I was trying to do was eliminate that B was, that this was the 7. I haven't managed to do it. If this is an 8, this is a 9. B always starts with 6, 7, or 8 as its X. Now, is that possible in this row? And what would B be? We said it would be 38, I think. A would be 28 and B would be 38. The total of this row would be 76, with an overlap of 31. I don't know. I'm not saying it's impossible yet. I haven't figured this out. I mean, it not seeming very likely is not grounds to proceed. So, if that's a 7, this is 8, that's 9. We've got a 7-6 pair here. And we've got 38 as the B sum everywhere, including at least 6 or 7 cells there, 6 or 7 cells here, 6 or 7 here, or maybe 8. And in this row, 2 lots of them. Wow, okay, I can't quite get my head around why not. I feel like why not is almost certain. Oh, okay, if this was a 6, 7, 8 trio, this pair of A's would be 4 and 5. Well, that one couldn't be the 4, 7, 8, 9 trio there, because these would be from 6, 7, 8. Could this one be a 4? 4, 7, 8, 9 would then go up here. This would be 6, 7, 8. That would be a 5. Getting to 28 with 2 out of 6, 7, 8 and 2 other numbers. I think that's possible. I don't think I've sunk that. This would be 4 with 7, 8, 9 here. goodness. 8, 9 would be there as well. That's interesting. What I'm really trying to do is prove this isn't 7, and I'm totally failing. So maybe I should think about it being 4. These would be 7, 8, 9. These would be 7 to 1, and this would be an 8, 9 pair. What would B be? Well, I don't know at all. I only know anything about what B would be if that was a 7 because of the leftovers here. That just doesn't apply. Okay, maybe I'm going to have to think about these across rows. Okay, let's do that. So, if these were 7 and 6, there would be 4 cells of overlap, adding up to the 11 of overlap, which would be made up of 1, 2, 3, 5. The other digits in the row would be 4, 8, and 9. I don't know. I just don't think I've got the wherewithal to say one way or the other whether this is right. Am I totally missing some obvious point? I think I probably am. But Nicholas is very clever, so maybe I'm not. Maybe I should just keep trying. Right, what about these B's? So we're postulating the 7 here and the 4 here, 7, 8, 9 there, 1 to 6 here, 8, 9 here. In fact, 8 here, 9 here. These would be 7 and 6, and B would always be a 37 sum. So we'd have a 4 here, and we'd have outies of either 2 or 3 cells in this column adding up to... No, we'd have a 7 here, and we'd have outies adding up to 7 of either 2 or 3 cells in this column. This would be 6 or 7. That would also be 6 or 7. We'd have similar outies up here of 1, 2, or 3 cells. Gosh, I don't get it. I don't get it. I haven't missed any rules. Okay, here's the first thing I'm going to do then. I'm going to say, could this be a pair with a 3-cell overlap? We know that the overlap in this row adds up to 11, so it can't be 1 cell. It's either 2 or 3 cells. If it was 3 cells, these digits would be 4 and 7. Now we would have the same problem with this line. These would have to be from the 1, 4, 7 group. Neither of them can be 1. B is not going to be 1 anywhere. So they would also be 4 and 7. And the 3 cells in the middle here, no, not the 3 cells in the middle, either those 3 cells or those 3 cells would add to 11, not using 4 or 7. And here we would again have an overlap of 3 cells. No, it's 2 cells. Sorry, the overlap with 4 and 7 is 3 cells. Sorry. Isn't it? Yeah. No. No, I'm being it's not the difference between 4 and 7. It's 11 minus the total of 4 and 7 that determines the overlap. Is it? It's 11 subtracted from... It's 9. I've lost my mind entirely. Right, I've now understood what I'm doing, and I now understand how to progress, and I'm sorry it has taken so long, but my brain has been off on a tangent for about 10 minutes. Right. Let's come at this from first principles, and it's very straightforward. It's very straightforward when you get it right. The sum, we know that A is 28 from both ends of this line. We know, therefore, that 2A sums to 56. But the sum of the individual digits in the row is 45. The overlap between the two lengths is 11. which is at least 2 cells of Sudoku numbers. That the length of the overlap is determined by these two added together minus 9, the number of cells. Okay, it's not utterly straightforward. However, if they were 7 and 6, the overlap would be 4 cells, and the 11 would be made up of 1, 2, 3, 5. Okay, we can't just proceed. I did think this through earlier, and I was right then, but I'm wrong now, but that's fine. These numbers can't both be 4 and 5 because there would be no overlap. They can't be 4 and 6 because the overlap would only be 1 cell. 4 plus 6 is 10, minus the 9 cells in the row is 1 overlap. So they are either 4 plus 7 with an overlap of 2 cells, 5 plus 6 with an overlap of 2 cells, or 5 plus 7 with an overlap, 4 plus 7 with an overlap of 2 cells, 5 plus 7 with an overlap of 3, or 6 plus 7 with an overlap of 4. That isn't easy to figure out. Okay, I'm no further forward after all. It's not straightforward at this point. I'm being a muppet. Okay, let's think about if this was an 8 and 37 was the number in this column. Sorry, I'm thinking about this being a 7 forces this to be an 8. This adds up to 38, that's the number. And then B would have to be 38 from both sides. These digits would be 6, 7, or 8. If they were 6 and 7, the overlap would be 4 cells. 6 plus 7 minus 9 is 4. And that overlap would equal 76 minus 45 is 31, which you cannot do in 4 cells. So they couldn't be 6 plus 7. So one of them would have to be an 8. But that would mean that the other one would be a 7, because that's the outie for an 8. If you're adding 8 cells to 38, the other digit in the row is a 7. So these two digits would be an 8 and a 7. And using the modularity rule, these two would be a 5. That's the only digit in this set that 7 can be in the same that 8 can be in the same modular set with, and a 4. Because whichever of these was a 7 would need a 4 here. Because that's the only other digit in the 1, 4, 7 modular set that isn't 7. Now, these cannot be a 5 and a 4 because there would be no overlap. So therefore, these are unable to be 6, 7, and 8, giving a 38 version of B, and this is not the 7-cell version of B, it's over this side. I find that quite complicated, but it is right. So that's a 4, these are 7, 8, 9. These are definitely, well, I mean, if I was to fully pencil mark these, that's the 1, 2, 3, 4, 5, 6, 7, adding up to 28. This is the 8, 9 pair. Now, the annoying thing is that leaves us none the wiser as to what B is. Previously, we were working on it being 38. Now we just don't know at all. But at least we've found out what the 4 and 7 are doing. That's taken me 20 minutes when it should have taken me 5. Never mind. I'm going to persevere as though I hadn't just made a complete numpty of myself. Right, the B down here is going to be 5, 6, or possibly, I suppose, 3 or 2. It's not going to be 1 because that can't replicate. Or when I say the B down here, I mean the X for the B. The maximum B can be now is those 6 cells. So we will now say that the absolute maximum for B is 45 minus 19 is 26, which has come down considerably from the 38 we were contemplating before. A is 28, we know that. That is just a known. What is B though? Okay, the minimum B is 3 down here, a 2 and a 1. So it's somewhere between 3 and 26. That's not an exciting number at the moment. Okay, how are we going to find out what B is? That digit is 4, 5, 6 or 7, and these two, that is in the same modular set and that is in a different one. I don't think that helps. Does this 8, 9 pair help? Ooh. 28. Do we know what that is? Well, we've got the overlap in this row of 11 in 2 or 3 cells. If it was in 3 cells, these would be a 6 and a 7. Now, what would happen to these? They would be a 3 and a 4. We can rule out 1 and 9 as possible. They would be a 3 and a 4. What does that mean? Nothing to me. Nothing, I tell you. That's if these were 6 and 7, so we had a 3-cell sum of overlap of 11 in the middle of this row. I mean, I could sort of mark the length of these as 4 and then maybe another 3 cells. This one is at least 4 and then maybe another up to 3 cells that way. I mean, these lengths are a bit unknown. Yeah, that's not great marking, is it? It doesn't really help. Let's take that out again. Okay, what is B? We need to get a fix on what B is. It can't be a 7 in this box. We've worked out that its maximum total is, what was it, 26. So it could never be a 7 anyway, whose minimum total is 28. So B is a total of 26 down to, well, I said 2 and 1 was the minimum. It's not, because we can't start with a 1 or they'd all be 1s. We therefore have to start with at least a 2 and a 3. So we're taking at least 5 cells here in. Now the minimum total for 5 cells for 2 Bs is 15. So B must be at least 8. B is somewhere between 8 and 26. And its first digit, its X, is somewhere between 2 and 6. So I'm literally going to mark those digits. Because look, this is 5 out of a set of 2, 3, 4, 5, 6, 7 now. If we could just eliminate either 2 or 7, either 7 from those or 2 from these, we would have a useful set in the bottom row. That can't be a 7 because these would have to not include 8 or 9. So that digit is not a 7. What about this one? If this was a 7, that would be the 28. This would be an 8-9 pair. Would that break anything? Why would an 8 or 9 break something there? I don't know. Okay, if this was a 6 and these added up to, say, 26, how are we going to get that total with a 5 and a 4? Oh, this can't be a 6-5-4 group, or that cell's broken. So one of these is no more than 3. And now the maximum size of B is 20. That's good. That's progress. B is now somewhere between 8 and 20, and we can never start B with a 6 as a result of that. because that would be 21 at least. And that has given us, has it given us, I thought that was going to give us a set, a quad or a quint or something. B can't start with 6. So B starts with 2, 3, 4 or 5. Oh, look, neither of these digits are 5. Oh, no. 2's in the same modular group as 5, so I don't know that. 2, 3, 4, 5, 6, 7. That's 2 digits from each modular group that are available here. How annoying. Okay, B is somewhere between 8 and 20. If it was 8, this would have to be a 2 with a 6 there. I'm not going to rule these out one at a time. That's not the way to go. B is somewhere between 8 and 20. If it was 20, this would use 3, 4, 5. That digit would be 6. That digit would be 7. This would be an 8-9 pair. If I can get 20 off the table, can't I? No, that 20 is not the decider, is it? I wish this was simple as AB. I'm missing the point here, I still think. 2, 3, 4 or 5 to get a target of B being between 8 and 20. Oh, well, okay, we're not going to have an overlap, are we? Is that of any interest? No, not really. Oh, we've got this column. A is 28. If this was a 5, B would be 17, because it would add those other digits in the column. So if this digit was a 5, B would be 17. Right, I think we might have a problem here. If these were both 17s, there'd be an underlap, a sort of gap in the middle of 11. What digits could you use? You couldn't use a 2 to make a 17 on either side. You'd have to either use 3 and 4 with the gap in the middle adding up to 11. Oh, I bet that's what does happen. That's if this was a 5 down here, which is the issue I'm trying to get rid of. No, let's think about the modular stuff. These are from the same modular set. If that was the 2, 5, 8 set, this digit would be a 2, that would be a 5. And we need the overlap from this side. So this would have to be 6 or 7, making that 3 or 4. The overlap would either be 11 in those cells or in those cells. I don't know. I don't know. It could be a 2 and a 5. If we were using the 3-6 group, we'd have a 3-6 on one side. Yeah, this is not how to do it. Oh, hang on. Have we got a triple going on here or something that I can't see? Oh, this is going to use the middly digit from one of the sets. Well, it's not going to be the set that is contributing those 2 digits, because one of those is going to be a middly digit. No, I don't know. this can't be a 4 because this would have to be 7, 8, 9, and that digit doesn't work. So this is 5 or 6 now. And either those 5 cells add to 28 or these 6. So either those 4 add to 17 or those 3 add to 17. And I've got a 5 or a 6 here. If this was 5, then I've got this further issue of that now being 6. And this being 4 or 7, extreme in one way or the other. What about the sum of these adding up to 28? If this was 5 and that was 6, that would be 11. That would be at least an 8, getting us to 19. Oh, no, this is a problem. If that's a 5, these add up to, yeah, that doesn't work. That's great. This does it. Right. If this purple digit was a 5, B would be worth 17. You could never start B with a 2. So those 2 would be a 3, 4. And that would be 6. And this would be adding 6 plus 5 plus 3 plus 4. And we all know that's 18. Plus at least 8 there, 26. Oh, plus, okay. We're trying to get to 28. I thought that didn't work. 5, 6, 3, 4. Is 18. We'd need these 2 to add up to 10, and that would be a 1 or a 2. Oh, it does work. It's probably wrong. Well, mind you, then we'd have used 6, 5, 4, 3 here. That would have to be a 7. Now we'd have an 8, 9 pair up here. And B, we would know would be 17. This digit would have to be a 3. B would be 17. This would then be a 6. I mean, this would all be prescribed. It's not, it doesn't quite break. It's so close. If I could say that wasn't 7, then I've done something. Or that this wasn't 5. That's what I want to say, actually, that this isn't 5. Because then we've got a huge drop down in possible B-ness. Okay, if B was 5, and therefore we've got 17 in this sum. If this B's X is 5, then if purple is 5, B is 17 then. Then we have to be using a 3 and a 4 from these sides. And then we've got a pair adding up to 11 in the underlap, either there or there. And these are a 3 and a 4. And that makes these definitely 6 and 7. And the overlap is 4 cells, which have to be 1, 2, 3, 5 in this row. This couldn't be a 5, 6 pair. Was that one of the postulated possibilities? No, it wasn't. These were a 3, 4 pair, so that wasn't what I was imagining. I haven't falsified it yet. I bet it's easy to do somehow. Because I'm sure it's not going to be right that B equals 17. But I haven't done it. Oh, Nikoli, what are you doing to me? Right. I need to find something else in the puzzle that's a bit more helpful. B, I believe, at the moment, is somewhere between 8 and 20. 20 because one of these has to be as little as 3. This one couldn't be 20. If it was 3, it would be a maximum of 16. This one would be a maximum of 14. So it would have to be this one that was the 3 if we were trying to go above 16. No, if we were trying to go, yeah, if we were trying to go above 16 as a total, this would be the 3, this would be 5, and therefore the total would be 17. The 3 would need a pair adding to 14 here. This would be a 4, and these would add to 13, which is not a very exciting total. And this is where I just start missing the point entirely. I don't know what I can do with this information. Okay, B. What's up with you, B? All the B's begin with 2, 3, 4 or 5. 17 is the absolute maximum. And if it's not 17, it's no more than 15. How can B be 17? This row would have 2 17s from each end, 34, and then an underlap of 11 in 2 cells. Not using 3 or 4, that underlap would be either 9 2 or 6 5. Oh, can you use 3 4 1 7 and 8 to make 2 sums of... No, it would be 1 7 8 9 and 2. I bet you can. Yeah, that's not the problem. Oh, Mark, come on. One of these must use either 5 or 6, surely. No, they could be a 4 7 pair and not use either a 5 or 6. Yeah, I just haven't worked this out at all. 4 7 as a pair here. 40 minutes in. I think this is so obvious and I can't do it. Okay, let's just take it calmly. If that was a 4-3-2 set, no. If this is a 3-4-5 set, that's 6 and this is 7. And then we've got an 8-9 pair up here, and that 6 is stopping us using 6-3 in these cells. Also, it's forcing 6, 3, 4, 5, 8 or 9 there, 1 or 2 here. These are 4 and 3, and one of them is achieving a 17 sum with a 3 and, well, it's not this one. This couldn't be a pair adding to 14 there, because 8 and 9 are both gone. So if that's a 5, it's this that is the 3. And these two that are either, well, they would have to be a 6-8 pair, very specifically. So we'd have 3, 6, 8, 5, 2, 1. Right, this is intriguing. This would be a 3-5 pair, definitely. 3, 6, 8, 5, 2, 1. A 4 starting a 17 sum here. A 7 here. Oh, I'm sure there's something else I can do just by common sense. I don't know what it is. 17. 3 cells there. Yeah, 3, 8, 6, that's possible. These two are the same set. But they are giving different totals. One's giving B and one's giving A. I was just about to go, oh, 2 and 5 can't work together, but that's just nonsense. Two on one side could only work with 3 or 4 on the other. I don't know. Oh, this can't be a 4-7 pair. Right, this can't be a 4-7 pair because both of those digits would have to be in the same modular sets and both would have to be 4, and that's nonsense. And if you can't have a 7 in one of these, no, once you can't have 4, once you can't have 4-7, you can't have a 4 in those. Because 4 in one of them needs 7 in the other to create a 2-cell overlap for the 11 in the overlap. So these don't contain 4. And that was obvious from the fact that 4 is the only digit from its set up here. But I've only just achieved that. Now, if either of these digits was a 5 for the B sum, that would be 6, and this would be 7, and this, neither of these can be 7, because the end digits in the row would have to be 8 and 9. That's the thing that's been obvious for ages. Perhaps it was a little harder to see that neither could be 4. Anyway, that is now a 5-6 pair. The overlap of 2 cells is either here or here and adds up to 11, not using 5-6. These are 5 or 6. We can't have a 4 up here. Oh, that's a 5-6 pair in the column, so we can't have 5 in these cells. Now B's X up here is a maximum of 3 cells and is a maximum number of 18. Oh, I was trying to rule out the 5 down here and 17. Oh, but I can, because one of these is a 5 and one is a 6. This digit can't be a 5 because they'd both be in the same modular set and they'd both be 5s. One of these is now a 2. The maximum sum for B is 11. B is now somewhere between 8 and 11. 5 doesn't work in this purple cell, or indeed in either of these, with the maximum sum for B being 11. That is a 2, 3, 4 set. This can't be 4. If that's a 6 even, okay, it's quite interesting if that's a 6. Because these add up to 9 definitely now. We've got 15 of our 28. These add up to 13. They would have to be 5, 8 if that's a 6. And if that's a 5, actually it's all a bit easier if that's a 5, so I don't know. But up here we've got 2 and 3. Oh, and here we're adding... If we were only adding 2 cells, 8 is the maximum. If this digit is a 2, 8 is the maximum we can get to in these 2 cells. And then these would, 5 of these cells, could be those 5 or those 5, would add to 16, would be 1, 2, 3, 4, 6. With a 2, 6 and a 3, 1, 4. Okay, I don't know the answer. B is somewhere between 8 and 11. That's what it is. It's somewhere between 8 and 11. No, one of these B's is going to start with a 4. The minimum sum for 4 cells starting with a 4 is a 10. B is somewhere between 10 and 11, and this can't be a 2 because it can't get there. That's a 3. B is 10 or 11 now. The 2 is followed by an 8 or a 9. the 3 by something else. B is 10 or 11. Oh no, it's not 11 because a 4 can't start a 4-cell sum of 11. The 4-cell sum of 11 is 1, 2, 3, 5. It doesn't have a 4 in it. So B is now 10. B is 10. One of these has an 8 coming after the 2. And the other one is 3 plus 2 digits that add to 7 that can't use 2 or 3. So in one case we've got 316 or 361, and in the other case we've got 28. That can't have an 8 in it. These middle cells must be from 4, 5, 7, 9, and they can't use 4. So they do use 5, 7, 9. That digit is an 8. This digit isn't. I'm really sure this shouldn't have taken me this long, but anyway. Now we're underway a bit. 10 is B. That could be a 4. Actually, I don't know. We're going to figure out these 5s and 6s at some point. If that's a 5, we now know it's taking in 11 there, and it would have to be 17 in those two. So this digit would be the other of 9 or 8. So I think this is either 9, 8 or 5. If that's a 6, this is a 5, and that's not a 5. If that's a 5, this is clearly not a 5. So this is not a 5. It could still be a 7 if that's an 8 and that's a 9. If it was 6, these 3 add up to 17 without a 6 in. Touch and go. I mean, possible either way. The overlap in this row is either, well, it is that cell and one of those two, and adds up to 11. Wow, that couldn't be in the overlap if it was 1. Oh, what about these? These have to be from different modular sets. And we've got 1, 2, 3, and 6 left as candidates. Not that helpful, except they can't be a 3, 6 pair. Right, one of these B's is a 2 with an 8 above it. So that digit is not an 8, because one of those two is a 2 with an 8 above it, making 10. So that's a 9, that's an 8. Now we narrow down this row. So if that's a 5, we're adding 11, 19, that's a 9. And if that's a 6, 10, 15, 23, we need a 5 here. That didn't narrow it down quite as much as I hoped. 8, 2, 4, 3, we've got that. 5, 6, something's going to give here. Something's going to give, but I don't know when. Don't know where. If that was a 2, this would be an 8. Oh, this can't be an 8. Goodness me, that's the 8. That's the 2 beneath it. This is the 4, topped by a 1, 2, 3, and that can't be a 1 anymore. This could still go 3, 6, 1 in that order, and that be 2, 8, and that be a 4. 4 in this row is in one of those two cells, so that didn't quite finish this. What about this box? 9, 8, 4, that can't be 4. There's a 7 in one of those two cells. That's not going to butter anything. Neither of those are 2. There's a 1 in one of these cells, which is not going to tell me anything either. I just need to get one of these B's or A's sorted out, and the others fall by modularity or something. Oh, hang on, this digit is not, oh no, all I know is it's not from this set of 2, 3, of 2, 5 or 3, 6. I don't know that it's not from either set. I was going to say it has to be a 4. In fact, if that was a 4, these would be from 1, 2, 3. This digit can't be from 1, 2, 3 because of this set, so that's not a 4. So that's now a 2, 3 pair. And one of them needs an 8 in one of these cells, and one of them is going 3, I'm guessing one, yeah, no, this one could go 3, 5, 2 instead of 3, 6, 1. That's so annoying. However, This digit can't be 7 or 9 on either reckoning. The only place for 7 in this box is here. This digit is a 9 because it's the only place in the box for it. Now the overlap of 2 cells adding up to 11 can't be 7, 4, and it can't be 5, 6. It's either 2, 9 or 3, 8. This central digit is in it, and it's not 2 or 8. It's either 3 or 9. Going with either an 8 on that side or a 2 on one side. And contributing to the sum. I wish that mattered. Maybe it does. Let's have a look at this column though. 4, 1, 2, 3, 7. This digit can't be 9. So 9's in one of those 2 cells. 3, 2, 8. There's an 8 somewhere here. That's not interesting. Okay, which side is 3, 6, 1? Ooh. I was just thinking about this. Oh, can this be a 7? That would be 8. That would be 9. What goes wrong with that? I don't know, but I think something does. But I don't know what it is. Oh, this is either 2, 8 or 3, 6, 1. If it was 3, 6, 1, that would be 5. There'd be nowhere for an 8. Where does 8 go in this box, Mark? It goes here. And that must be a 2. And now we know. This is 3, that's 2. This is 5 in the same modular set, that is 6. The overlap is these 2 cells, which is 2, 9. Let's get rid of the colour. I mean, I don't really need any of the colour I've got anymore. We're just going to do the puzzle. Right, that 3 goes 6. I said I don't need colour anymore. 6, 1. This 2 goes with an 8. Oh, that didn't rule out 7 from here, annoyingly. That 6, though, makes this a 5, which makes this a 9. And now this adds up to the right number. Yes. These are 1, 6, 7 as a triple over here. This is a different modular group from either 2, 5, 8 or 3, 6, 9. It's from 1, 4, 7. It sees 1, 7 in the box. That's the 8 in the column. This is now a 1, 7 pair. That's the 1 in my 1, 2, 3. This digit is a 6. That's a 3, 4, 5 set. This is a 2 by elimination. This is a 9, 5 pair. That's a 4. Okay, this is good. That B's done. That B's done. That B's done. That B's done. This one has to be 3, 6, 1 to add up to 10. That B's done. So that's a 5 now, and this can't be a 5. We've found 5 in box 6. All the B's are done. This set adds up to 28, 11, 16. These add up to 12. They're 8, 4. We know the order thanks to the 8, 4 above. That's a 3. This is a 1, and now I check that these add up to 28. And they do. And this is the last A sum that I'm going to have to do up here, which is either 7 cells, and that's a 9, or it's 6 cells, and these add up to 17, in which case those two add up to 9, in which the even digit is a 6. So either this is a 3, 6 pair, or that's a 9. Well, I know it's modularity now. Is that any use? No. I'm going to have to kind of do the rest by Sudoku, but if that's 3 or 6, so is that. That's what I should try and remember. I'm gonna just colour them to try and help me remember that. Okay, down here we've got 4, 5, 7 still to go in the box. I don't think there's any other clues left to do. I've got this modular pair to consider, and one of them is a 2 by Sudoku. So the other one is from the 3 or 6, and there's a 1 here. Oh, one of those is 3 or 6. Yeah, okay. Oh no, these are modular too. What do I know? I don't know much about them though. I think I have to just do Sudoku. That 9 makes this a 7. That makes this a 9. That's a 1, that's a 6, this is 7, that's 1. That gives us 7 in the box. That 7 in the box gives us 5, 7 up there, 5, 4 down here. There's an 8 needed in this row there. These are from 2, 3, 9. One of them's a 9. That is the 4 in the column. These are from 2, 3, 5. 7, 2, 9, 5, 1. There's an 8 in the box there and a 4 there. The other two are a 3, 6 pair. Why do I get the sense that 3, 6 are going to be troublesome? That's not a 1, it's a 3 or a 6. That's a 2. Might be wrong, might be right about that. These digits are from 1, 3, 6. I've got so little feeding over to the left. Right, oh, hang on. If that was a 6, I was saying these two had to add up to 9 and the even digit would be a 6. Well, that would clash with the 6. So that's a 7, that's a 9. All of my A's and B's are done. They were not as easy as A, B to me, but they probably weren't that hard. Now, that gives me a 7 here, which really ought to do something. That can't be a 9, so we've found 9. Now one of these two is a 9, it's got to be there. Now we can look at this, which has to be from the 1, 4, 7 set, and it's C's 1 and 4. So that is a 7. Thank you, modular line. This is 3 or 6. In the row, these are from 1, 3, 6. In this row, they're from 3, 5, 6. 5, 8, 4, 1, 9. Oh, look, that's a 3, 6 pair now. Okay, 3 6s are helpful, not unhelpful. That 2 gives me 3 and 5. This column must be disintegrating for me. It is. That is a 5 by Sudoku. And look, we've got the 6 in this row, and that's going to sort out all my 3, 6 issues all over the board. Fantastic. 3, 6, 1, 6. 2 and 3 here are done, and now I can do 1 and 3 up here, and that's 3 in the corner to finish with. That's 3 in the corner. That's 3 in the spotlight. What a lovely puzzle, but what a botch I made at the beginning. I'd be very interested to hear how you did. Took me an hour nearly, and it shouldn't have done, but I've enjoyed the whole journey, and that is the key thing with variant Sudoku. Do try more variant Sudoku. It's just great fun. And I'll see you later. Bye for now.